Bismillahirrahmanirrahim. My name is Alina Mazhar and I am from BS Chemistry Department. The topic of my presentation is membrane technology used in reverse osmosis, dialysis and wastewater treatment. Membrane technology. Membrane technology is a separation process that covers a broad range of problems from particles to molecules, and a wide variety of membrane are available to design process. Purpose of membrane technology separate the fluid mixtures in many different applications. They can separate the material based on the size, electric nature, physical properties, and are used widely in the food processing and chemical industries as well as in water treatment. Here, the membrane technology used in many fields like reverse osmosis, dialysis, wastewater treatment, microfiltration, ultrafiltration, and nanofiltration. Membrane used in many fields: air protection, energetics, breeding, agriculture, soil protection, food, medicine, pharmacy, and water protection. Here, the process is reverse osmosis. Reverse osmosis is a water purification process that uses a partially permeable membrane to separate ions, unwanted molecules, and larger particles from drinking water. This is a diagram which shows how the osmosis works. A solution that is less concentrated will have a natural tendency to migrate to a solution with a higher concentration. A semi-permeable membrane is a membrane that will allow some atoms or molecules to pass but not others. A simple example is a screen door. It allows the air molecules to pass through but not pests or anything larger than holes in the screen door. And how does the reverse osmosis work? Reverse osmosis works by using a high pressure pump to increase the pressure on the salt side of the reverse osmosis and force the water across the semi-permeable reverse osmosis membrane, leaving almost all of the dissolved salts behind the reject stream. The designated water that is demineralized or deionized is called the permeate water. The water streams that carries the concentrated contaminants that did not pass through the reverse osmosis membrane is called the reject stream. It is important to understand that a reverse osmosis system implies cross the filtration rather than standard filtration where the contaminants are collected within the filter media. With cross filtration, the solution passes through the filter or across the filter with two outlets. The filtered water goes one way and the contaminant water goes another way. Dependent on the following factors: influent solute concentration, water flux rate, pressure, and required the pressure amount. Desalination, useful for the areas that have either no or limited surface water or groundwater. Reverse osmosis is the most common method of desalination. Although 85% of desalinated water is produced in the multi-stage flash plants. Seawater reverse osmosis, no heating or phase change are needed. Energy requirements are low in comparison to other processes of desalination, but are still much higher than those required for other forms of water supply. The Ashkelon seawater reverse osmosis desalination plant in Israel is the largest in the world. Desalination of brackish water, desalination of seawater, production of ultra pure water, wastewater treatment. Reverse osmosis disadvantages: household reverse osmosis units use a lot of water because they have a low back pressure. As a result, they recover only 5 to 15% of water entering the system. The remainder is discharged as the wastewater, and reverse osmosis unit delivering 5 gallons of treated water per day may discharge 40 to 90 gallons of wastewater per day to the septic system. Large scale industries have a production of efficiency of closer to 48% because they can generate the high pressure needed for reverse osmosis filtration. Dialysis. The next process is the dialysis. Dialysis, a process by using by which the small molecules are selectively removed from a sample containing the mixture of both simple and large molecules. Semi-permeable membrane is used that allows the small molecules to pass freely through, holding the large molecules inside. Membranes made up of the cellulose derivatives. Cellulose, naturally occurring homopolymer of glucose, and the glucose units connected through the beta 1 to 4 linkage. Molecular weight cutoff. Dialysis membrane characterized by their nominal molecular weight cutoff depends primarily on the pore size of the membrane. The separation is based not only the size but also on the shape and the charge of molecule. Molecules small enough to pass through the tubing tend to move cut or out of the dialysis bag in the direction of decreasing concentrations. Larger molecules that have dimensions significantly greater than the pore diameter are retained inside the dialysis bag. Pretreatment of dialysis membrane. To remove the undesirable impurities such as the glycerol, heavy metals, sulfides, membranes generally supplied with 10% glycerol. Always store the membrane at 4 Celsius in the immersed condition. Since the membrane is cellulose, nature high affinity for heavy metals, and these heavy metals bond to tubing during the manufacture. Heavy metals can be removed by boiling the tube in 10 mm EDTA solution. To remove the sulfide, the tube is boiled for 10 minutes in 2% sodium bicarbonate. Procedure. Tubing of required length is taken and both inside and outside of the tubing is rinsed with water. One end of the tubing is tied securely with the thread through the open end. Fill the tubing with the diluted water and check for leakage. Water is removed and the sample solution is filled 2 to 3% using a pipette or funnel. The open end is closed securely by tying with a thread. The bag is placed in a buffer solution and dialyzed for 3 to 4 hours at required temperature. Small molecules will be removed from the bag and buffer can be changed after 3 to 4 hours. Factors affecting the rate of dialysis. Solvent. The rate of dialysis is the highest in distilled water, and most biomolecules like enzymes, proteins, and nucleic acid is not stable in distilled water. Dialysis is done in buffer of desired pH and ionic strength in which the molecules are stable. Temperature. Rate of dialysis increased by increasing the temperature of the solvent. Temperature. Alpha rate of diffusion of small molecules, but most of the macromolecules are sensitive to high temperature and hence done at 4 Celsius. Pressure directly proportional rate of dialysis. Concentration gradient. The driving force in dialysis is concentration gradient. Large concentration gradient between inside and outside of bag increase the rate of dialysis. Diffusion constant. Small spherical molecules are dialysis faster than large fibrous molecules. Thickness, areas, and prosperity of membrane. Larger membrane area affect the dialysis than the small membrane area. High prosperity increase the dialysis than the low prosperity. Reverse dialysis and electrodialysis. During the dialysis, osmosis causes the water molecules to enter the dialysis bag. If higher molecular weight compared compound like Sifdex or sucrose is used than that of a solvent, the water molecules move out of the dialysis bag. This process is known as the reverse dialysis. In this process, the amount of water can be reduced to few ml. Electrodialysis. Application of electric field enhance the rate of dialysis known as the electrodialysis. Cations and anions exchange membrane are available for electrodialysis. And the wastewater treatment, the next process is wastewater treatment is a term that is used to describe the waste material that includes industrial liquid waste and sewage waste that is collected in towns and urban areas and treated at urban wastewater treatment plants. Wastewater treatment, a process to convert the wastewater, which is water no longer needed or suitable for its most recent use, into an effluent that can be either returned to the water cycle with the minimum environmental issues or reused. Where does the wastewater come from? Residences, commercial institutions, and dairy and industrial establishment. Where does it all go? This picture shows that where does it all goes. Why treat wastewater? Causes a demand for DO levels of streams, add nutrients, increase the suspended soils or sediments in streams. Levels of treatment: primary and secondary. Removal by physical separation of grit and large objects, sedimentation and screening of large debris. Secondary: biological and chemical treatment, aerobic microbiological process. Activated sludge process. Primary wastewater mixed with bacteria rich sludge and air or oxygen is pumped into the mixture. Both aerobic and anaerobic bacteria may exist. Promotes bacterial growth and decomposition of organic matter. BOD removal is approximately 85%. Microbial removal by the activated sludge. Aeration tank. 5 physical components: aeration tank, aeration source, secondary clarifiers, activated sludge outflow line, and effluent outflow line. Trickling filters. Trickling filters are bed made of coke, limestone chips, or specially fabricated plastic media. Optimize their thickness by insect or worm grazing. The primary wastewater is sprayed over the filter and microbes decompose organic material aerobically. Low pathogen removal. When the treatment is done, effluent back to stream after. Sludge very nutrient rich. Sludge treatment process: thickening, digestion, pathogen inactivation and odor control, conditioning, improved dewatering with alum and high temperature, dewatering, pathogen inactivation and odor control, inclination, volume and weight reduction, final disposal.